All right, here we go. August 2024, Tempo community call. How many of these have we done? It's been a few years. 30, 40? I don't know. I'm going to look that up after this call. Today, we have an action-packed agenda. Tempo 2.6 should be coming out, I think, in the next week or two. So we'll look at some of the improvements there. We have some TraceQL improvements. We've got a lot of performance improvements, and we have our very own Zach Leslie on call, who will talk about, okay, I did not prep him for this. We'll talk about, we recently made a really nice improvement to polling, baseline polling memory usage that he did in the past couple of weeks. We'll talk about that in a second. And we'll look at an Explore Traces app preview. This will be officially announced. It doesn't exist yet, so don't tell anyone, but it will be officially announced, I think, the end of September at ObservabilityCon New York. So we'll do a big reveal there, an announcement, but I want to show you all the community, kind of where we are. I think we did a preview last month. You'll see how much progress we've made and talk about what we're looking to get done in the next couple weeks before we release for real. All right, so Tempo 2.6, we'll start there. Has a lot of nice TraceQL features. I was really hoping Jenny Pham would be on, because Jenny Pham wrote a lot of these. I think she'd do a good job of demoing them. But I will quickly discuss some of them. These are some longer-term requests from the community and from ourselves internally as well for support for some of the more, I would say, esoteric OTel, open telemetry data types. Maybe not even esoteric, but certainly less common than just standard attributes. So here's our doc. I'll use this as kind of a guide here. We're going to talk about links and attributes, talk about arrays, and scope. So links are an awesome addition. We can do, links and events. I should change that, shouldn't I? Links, events. So in a given span, you can have a set of links to other spans. I'm going to look for them like this real fast. Oops, I didn't need to do that. Notice that Grafana does not know about this syntax yet. We're still working on that being added on the Grafana side. But we can now query for links. So any span in the old open tracing, as well as the modern open telemetry object model, can reference other spans. So we have the ability to link or query those directly now. You can query them by trace ID. So that's what I did here. I just asked for really anything, right? Does not equal blank. But if we had a specific trace ID, we could, same with span ID. If we had a specific span ID, I could do span ID here, like this, and I could search for links that have a span ID. And then all links can also have attributes. So this has, for some reason, an empty follows from attribute. But you can attach attributes to your links, which maybe you are used to describe them. And you can query those nicely as well. So I'm going to actually do that real fast. I don't know why, but these links a lot of time have an attribute named follow from that's empty. So we're going to look for a link. The dot means attribute, follows from. We should be able to find all of these links. So if for some reason we had attached some kind of attributes to our links, we could search by those. Or maybe you just want to find any trace anywhere that links to a specific trace. Maybe you have a problematic one and you want to see traces that surround that. You can use this new syntax. Also exciting, events. So event has a name. This is an intrinsic field in the event. So I'm going to use the colon, event colon name does not equal empty. And this will let me find all kinds of different events in my data. So here's a span with two events, one named query and one named status. This is another thing you need to improve in Grafana. This message here is the name, essentially. And the query is another attribute. So we can query by the intrinsic name. We can query by attributes. So let's try this query one. Query by the query event. That query, let's say, does not equal empty. That's simple enough, and will let us find all kinds of neat things. So we can do these attributes. We can do the name. And this really clever addition I love. We can also say, how long has it been since, when has the event occurred since the start of the span? So the start, I believe, is what it's called. And this might let us find perhaps let's say we have an event that marks a mutex. We could use this to find times where it took like a second or 2 seconds or 5 seconds after the beginning of the span to acquire that mutex. This could help us find all kinds of great situations where an event was very late in the span, which might indicate it took a long time to establish a TCP connection or collect a mutex or some other internal event on the span during the processing of the span. So event has name and time since start intrinsics and all attributes. Link has trace ID, span ID, intrinsics, and all attributes. And then another addition with vparquet4 as the default in 2.6, all attributes will be arrays now. So span dot, I don't even know an array, I apologize, but if I had an array attribute, this will now search the array attribute for a value. So let's say I had an array attribute with some values. This will now correctly return when this did not work before vparquet4. So we have this limited array attribute support. We're looking to extend that. Right now, it will now search correctly inside of array attributes, and we're looking for more precise syntax there. But you can, with vparquet4 and 2.6, correctly search arrays, which you could not do before. So events, links, arrays are nice, new, awesome things with TraceQL in 2.6. This is borderline. We have a PRF now. I'll just mention it quickly, but we're also looking at adding the scope. The scope is the open telemetry scope that records the, I thought I had some good examples here, but I do not seem to, but it records the instrumentation. So if I had some spans, this is not merged yet, but I think it's quite close. In fact, I am going to review it later today. But I can't find a good span with it. But you can record your instrumentation library and instrumentation name, and that information is on your span. We will make that queryable as well. Hopefully in 2.6, I think it's going to happen, but I'm not sure. Jenny Pham has been killing it lately. Metrics performance, we have some performance improvements in 2.6 for metrics. These performance improvements will increase TCO. I think the blog post will have some details. Kim on this call is now very mad at me because I've not mentioned this before and she needs to write the release notes. And so I think we're going to get some details about how to improve performance. It's something of a TCO increase, but we're really looking forward to the future in the next couple quarters of releasing a version of Tempo built around RF1 that has top-tier metrics and search performance with TCO reduction. So there will be some options in 2.6 to make metrics faster at the cost of more blocks, more CPU, more memory. And then a future version that we are actively working on, it's our primary project, I would say right now, is to reduce total Tempo TCO by building an RF1 architecture and building metrics and trace search around it. And then I will hand off to Zach Leslie, who recently released a very massive performance improvement in terms of memory consumption on most Tempo components by mucking around with the block meta. What do you got, Zach?
Yeah, I was just trying to pull up the screenshot.
Let me, good call. Let me stop presenting here.
And I'll just get our time window. So yeah, we took the opportunity to find some improvements in our block list. We kind of bumped into some challenges we weren't expecting a year ago, we'll say. And our block list has really been growing internally for various reasons. And so we wanted to reduce the memory of the block list itself. And so we noticed that we had these commonalities between a lot of the blocks, and one of those pieces was the dedicated columns. So we started interning, I guess you would call it interning, dedicated columns, so that we now only unmarshal when we have not seen that string of JSON before. And then also we dropped a couple fields that were not used or very lightly used, and replaced their implementations a little bit, clean that up, shrink the struct size overall. And I think we also reduced like an int32 to an int8, if I recall. And so that helped us shrink this up. So you can see pretty good improvement here. I think if you're running a large cluster, this is only showing the query errors. But if you're running a large cluster, you will probably notice a memory improvement. Yeah, so we're going from 2 to 1.25 at the floor. So that's not terrible, depending on how many queries and pollers you're running.
Yep. I think our large cluster is like 2 million or so blocks. Is that right?
Yeah, I think so. Yeah, we've got a couple
scary number of blocks. So
Yeah.
we were seeing a lot of overhead on both marshaling, unmarshaling, as well as just holding those in memory. And Zach cleaned that up a lot. Hopefully, maybe even some future stuff, maybe different encoding. I think there's some options on the table for even breaking that down a bit
Yeah,
more.
a little bit of exploration. It'll probably take me a couple weeks to get back to that, but yeah, I think there's stuff on the horizon anyway.
Very cool. Thanks, Zach.
You bet.
All right, team. Lastly, and mostly, demo app. This is, I think, the most exciting work, I'm going to say, that's happening in Tempo. It's kind of not in Tempo. It's outside of Tempo. It's in Grafana, but it's really the culmination of years of work in Tempo. The ability to do metrics queries, all that TraceQL language, the structural operators, all of the features that you have seen roll out in Tempo over the past 2 years, 3 years now, have enabled the creation of this application right here. So this is pretty busy. I think we have a lot of work here to clean this up, tighten it up, communicate what's happening here better. But I think the power of this is amazing. I use it now basically every day. I'll sit down in the morning and find some new issue in our applications, in our infrastructure, and I use this app to try to track those down so I can improve the app and improve the experience. But let's talk a little bit about what it does now, and kind of what the goals are in the next month or so. So from our traces, we can view all kinds of different details of our applications, right? Like the number of errors that occurred, the duration of our traces, and just the total rate. Let's focus on errors. Let's pretend we're in this situation where we have a spike in errors on some service, or maybe we just want to go look at errors generally. Let's do that. I just want to find something that's failing in my infrastructure. This is all demo data. You can see SE demos, the cluster up here. This is all demo data, so this is just synthetic data at the moment, but I use this in a real cluster, like I said, kind of daily. So this particular service here seems to be failing. I have something on front-end proxy, but look at Mythical Requester having a lot more. Let me add that and filter down some. I can then do breakdowns. I can look at this error graph broken down by all kinds of attributes. I can click any of these things and see how these errors are split. Or I can just click this investigate button here, and it will automatically show me the error split across all different kinds of attributes. So I can see, for instance, kind or name. Span name has both errors and not errors, in fact, and about the same. So we can correlate across the attributes on the span and see where the error is occurring. And like span level, okay, the error level is correlated with errors. The error status code is correlated with errors. What this is telling me is there's no strong correlation between an attribute, any attribute on the span, and the errors, which is a good clue. It means that what is happening may be happening below this particular span. The error isn't occurring on the span. It's kind of hard to tell, but we're using tracing here, right? Tracing involves context propagation. We can see our whole tree, our whole request. And so the application will allow me to then look below this Mythical Requester. So now I'm looking for failures in the tree anywhere beneath it. This is an aggregate view of all errors in my infrastructure that is below this span. And now I can immediately see that the thing that's failing is this Postgres query insert. So I can jump to a number of different traces that are having this failure. And I can maybe use this to diagnose. Maybe there's an error here. Maybe I'm going to now go review that database, metrics, or other signals related to this database to see perhaps what's going on. Another very cool feature of this application, since these are traces, and tracing is highly structured metadata. Now that I know there's a database failure, I could also do this. Because this is so structured, I can go look at all database calls across all my applications and see failures. So now I can see the error rate of the error rate of all database calls. This is that Postgres database failure. Let me try my breakdown now. So before I wasn't getting anything because the error was actually kind of below my current span. But now I'm on the current span. Now I'm looking at the errors of the database. I can see now clearly that Postgres query inserts are failing a lot more than other queries. So like selects are fine. These deletes seem to be fine. Whatever this stuff is fine. But something about inserts on this database is definitely having issues. I can see this Postgres database itself. Maybe I have a bunch of databases. I could see maybe if one is failing, they would all be up here. I'd be able to see the red bar was taller. On the one that's we're failing, the green bar would be shorter. This would let me quickly see, is this a query issue? Is there a specific query that's failing? Is this a database issue? I can immediately understand, is it in a specific cluster? Is it a specific namespace? Is it a specific resource? All of these, this attribute view is going to immediately visually let me see that. And what I've discovered is that these inserts seem to be failing more than succeeding. Selects are fine, other things are fine. Maybe I go dig in some database logs. I have a lot of very strong clues that I can now use to further my investigation. In moments, I was able to identify a failing database, the kind of query that was failing. I have all these good details. I'm going to go figure out now, why that issue is failing. Similar, I'll do one quick additional one. Let's talk about duration real fast. I could do duration of database calls. I could see which database calls were slow, but I really like the structural thing. So we're going to go back to the full traces. Let's find out why. I don't even know what this thing is. DITL demo. Let's see if we can't figure out why this thing is slow. So on the errors, when I click structure, I was able to see the structure of errors beneath my root span, right? I was able to immediately see what was going on there. For duration, I am able to see the longest running spans beneath the thing I care about. So I was looking at this DITL demo thing, and this front-end proxy is one of my longer spans, and this document load seems quite long. It's identifying for me in aggregate that resource fetch, whatever that thing is a longer running span beneath this. Maybe I need to go investigate this DITL, this resource fetch thing. It's also identifying to me the average length of all these different spans. It's getting rid of, see these small ones, it's getting rid of the small ones, throwing out anything that's less impactful, and it's highlighting the longest running spans. So this structure tab lets me see descendant long spans, long duration spans, descendant errors, and allows me to hopefully quickly jump to traces and then maybe determine what's happening. I'm going to click investigate slowest for fun real fast. I can see that this is showing me posts are significantly slower than other methods, and it looks like gets are quite quick. So something about my posts are slow. This particular span name, document load, is very slow. Maybe I want to add that. Let me add document load real fast. So now I'm filtered down to document load, and I'm able to, again, do my breakdown again. So we have different tools here. This investigation allows me to look for correlations in the span attributes. And then the structural allows me to look down the tree for longer running spans, as well as errors and other things that might be impacting the top of the trace. So I think this is super cool. If you are anywhere in the New York area towards the end of August, come to ObservabilityCon, find me, let's chat some. I'm going to be demoing this there as well. It'll look a lot better, a lot more clean, I hope. Get rid of some of these rougher edges. And I think that's basically it. We've covered most of the stuff. Jenny Fam's Room joined, which I appreciate. Thank you, Jenny Fam's Room, for joining the call in the last few minutes. If there are any questions, which I am sure there are many questions, but if there are any questions, feel free to ask. Otherwise,
Sure, I got a question.
Yeah.
So you were showing off the events and the links.
Yeah.
And there was this a syntax I don't think I've seen before, where it was the colon because it was an intrinsic.
Yep.
So can you talk a little bit about the difference between when you're searching for intrinsic event compared to an event name on the spans?
Yep. Good call. Good eyeballs there. This is a change we made recently to TraceQL. By recently, I mean 3 to 6 months ago, or maybe even longer. We spec'd it out, and it's slowly been rolling out in the past few Tempo releases. Even Grafana is not quite aware of this. But initially, we named all of our intrinsics in kind of a global namespace, right? Like name is really span name, right? I can search for span names essentially. Ooh, I'm gonna type it doesn't matter. And duration is span duration. And then we also added this thing called trace duration, and it got this kind of unwieldy name, trace duration. And then we started adding events and links, and we knew those had intrinsic values as well, and we knew scope was going to have intrinsic values, and we realized this was going to turn into a mess. Event, duration, event, name, what do all these things mean, right? So we decided to extend the language a bit and add the ability to scope intrinsics, and it's for clarity, essentially. So span name is this. I don't know what is greater than, whatever, food. It's not going to match anything. So span colon name is an intrinsic. Anytime you see colon, it's an intrinsic. We can do event name. Now our names are a bit cleaner. They communicate better what is occurring. We don't have this like kind of frustrating camel case situation where you're wondering a bit. I just find that the names themselves to be a little bit more aesthetically pleasing. And like I said, I think they communicate better what's going on because you see the colon, immediately intrinsic versus dot would be attribute. So that is a change we made and has been kind of rolling out. I don't think we have any plans to remove the old ones. We'll probably leave them there forever. But we'll probably slowly encourage the new ones through documentations and examples, because I just think this is way clearer. Span colon duration is telling me a lot more than just duration, right? And then trace colon duration. A user, if they saw this, would, I think, have a much better understanding of what was being queried versus the older names. So we kind of realized, I think I was frustrated a bit with the name trace duration when I first put it in, but it's so valuable we put it in. I think once we were addressing how to do events and links, we saw very clearly that it was not a good path forward to just chuck a giant bag of intrinsics at the user. And I think the scoping is really going to help people understand better what's happening.
Definitely. Cool. Yeah. Thanks for the explanation.
Yeah, good question. Cool. Anything else, team? I haven't eaten lunch. I'm starving. It's 1 o'clock here.
Go get some food.
I had a lemon blueberry bread for breakfast. Go get some food.
You said you've been baking.
This has been in the freezer for a while. Blueberry season's over, but it was delicious.
Awesome. Yeah, that sounds great.
All right, team. Take care, everybody. I will see you next month. We will have the community call on time next month, I swear. And we'll be talking about 2.6, surely. So everybody take care, and we'll see you when we see you.
All right. Bye, everybody.